What does it mean for a volcano to be truly extinct? For millions of people living in bustling urban centers, the ground beneath their feet may seem unyieldingly solid, a foundation of concrete and steel that supports modern life. Yet, for some cities, this foundation hides a startling secret. They are built on or near extinct volcanoes, geological giants that have been silent for centuries or even millennia. The term extinct suggests finality, a reassurance that these volcanoes pose no threat. But is that assumption as safe as it seems? This exploration uncovers the surprising reality of cities perched atop these sleeping giants, revealing the geological risks that linger beneath the surface and challenging our understanding of urban safety. The deceptive tranquility of extinct volcanoes can lull cities into a false sense of security. Many assume that an extinct volcano is one that will never erupt again, but the geological definition is more nuanced. An extinct volcano is one that has not erupted in historical times and is unlikely to erupt again due to the cessation of its magma supply. However, unlikely is not the same as impossible. Subtle shifts in the Earth's crust, changes in magma chambers, or even external triggers like earthquakes could, in rare cases, reawaken these seemingly dormant systems. This video delves into the hidden risks faced by urban centers built on or near extinct volcanoes, spotlighting cities where the ground may not be as stable as residents believe. To grasp the unseen threat, it's essential to understand what makes a volcano extinct. Volcanoes are classified into three categories: active, dormant, and extinct. Active volcanoes have erupted recently and are expected to erupt again, while dormant volcanoes have not erupted in historical times but retain the potential to become active. Extinct volcanoes, by contrast, are those with no recent activity and no expected eruptions due to a lack of magma supply. However, geological processes are not always predictable. Some volcanoes classified as extinct have shown signs of activity after thousands of years of silence, challenging the certainty of their designation. The Earth's crust is a dynamic system, constantly shifting and evolving. Beneath extinct volcanoes, magma chambers may cool and solidify, but they can still harbor residual heat or gases. In rare cases, tectonic activity or the injection of new magma from deeper sources can destabilize these systems. Cities built on such volcanoes may face risks not only from eruptions, but also from associated hazards like ground deformation, gas emissions, or seismic activity. These risks, though rare, are often overlooked in urban planning, as the long timescales of geological activity contrast with the short-term priorities of city development. Several major cities around the world are built on or near extinct volcanoes, each with its own unique geological story. These examples illustrate the diversity of risks and the ways in which urban areas have grown complacent about their volcanic foundations. Lisbon, the vibrant capital of Portugal, is famously known as the City of Seven Hills. While its picturesque landscape is often attributed to tectonic uplift, parts of the region are linked to the extinct Lisbon volcanic complex. This ancient volcanic field, active millions of years ago, has shaped the region's topography. The volcanic rocks beneath Lisbon are now considered stable, but the area is not immune to seismic activity. Portugal sits near the boundary of the Eurasian and African tectonic plates, and earthquakes, such as the devastating 1755 Lisbon earthquake, highlight the region's geological volatility. While the volcanoes themselves are extinct, their legacy includes fault lines that could pose risks to the city's infrastructure. Auckland, New Zealand's largest city, sits atop the Auckland volcanic field, a collection of around 50 extinct volcanic cones. The last eruption occurred approximately 600 years ago, forming Rangitoto Island, a prominent landmark visible from the city. While the field is classified as extinct, geologists caution that new volcanic activity cannot be entirely ruled out. The field is monogenetic, meaning each volcano typically erupts only once, but new vents could form elsewhere in the region. Auckland's urban sprawl has enveloped these volcanic cones, with homes, parks, and businesses built directly on them. The city's residents live with the knowledge of this geological heritage, yet the potential for ground swelling, gas emissions, or even a new eruption remains a distant but unsettling possibility. Mexico City, one of the world's largest urban centers, lies in a basin surrounded by volcanic landscapes. While the nearby Popocatépetl is an active volcano, the city itself is built on the remnants of older, extinct volcanic systems within the Trans-Mexican volcanic belt. These ancient volcanoes have left behind layers of ash and lava that form the bedrock of the city. However, Mexico City faces additional geological challenges due to its location on a former lake bed, which amplifies seismic activity and causes subsidence. The extinct volcanoes may not erupt, but their presence contributes to the region's complex geological risks, including earthquakes and soil instability, which threaten the city's infrastructure. Honolulu, the capital of Hawaii, is built on the slopes of the extinct Ko'olau and Waianae volcanoes. These shield volcanoes, formed millions of years ago, are no longer active, but their eroded remnants shape the island of Oahu. The city's picturesque setting belies its geological complexity. While the volcanoes are considered extinct, Honolulu is not immune to seismic activity, as the Hawaiian Islands sit on a tectonic hotspot. Additionally, the porous volcanic rock beneath the city can complicate water management and infrastructure stability. The allure of Honolulu's volcanic landscape masks these subtle risks, which are rarely considered in daily life. The dangers posed by extinct volcanoes extend beyond the unlikely event of an eruption. Urban areas built on such volcanoes face a range of geological hazards that can disrupt city life and infrastructure. Extinct volcanoes are often associated with fault systems, as volcanic activity shapes the Earth's crust over millions of years. These faults can remain active long after the volcanoes themselves have gone silent. Earthquakes, even minor ones, can damage buildings, roads, and utilities, particularly in densely populated urban areas. Cities like Lisbon and Mexico City, with their proximity to fault lines, are particularly vulnerable. Volcanic landscapes are prone to ground deformation, where the Earth's surface shifts due to changes in underlying magma chambers or tectonic activity. In cities like Auckland, even minor swelling or sinking of the ground can disrupt infrastructure, crack roads, or destabilize buildings. Mexico City's subsidence, exacerbated by its volcanic and lakebed geology, is a prime example of how these processes can challenge urban resilience. Even extinct volcanoes can release gases like carbon dioxide or sulfur dioxide from residual magma chambers. In rare cases, these emissions can accumulate in low-lying areas, posing health risks to residents. Hydrothermal systems, where heated groundwater interacts with volcanic rock, can also cause localized instability or chemical contamination. While these risks are less dramatic than eruptions, they can have significant long-term impacts on urban environments. The risks associated with extinct volcanoes are often overlooked for several reasons. First, the long timescales of geological activity make these threats seem remote compared to immediate concerns like traffic, housing, or economic development. Second, the classification of a volcano as extinct creates a false sense of security, leading city planners and residents to dismiss potential risks. Finally, urban expansion often outpaces geological research, with cities growing over volcanic landscapes before their full implications are understood. While the risks of extinct volcanoes are rare, they are not insurmountable. Cities can take proactive steps to mitigate these threats and enhance urban resilience. Advanced monitoring techniques, such as seismic sensors and satellite-based ground deformation tracking, can provide early warnings of geological activity. Cities like Auckland have implemented monitoring programs to detect changes in the volcanic field, offering valuable data for urban planning and emergency preparedness. Building codes and urban planning can account for geological risks by prioritizing earthquake-resistant designs and flexible infrastructure. In Mexico City, Efforts to address subsidence and seismic risks include retrofitting buildings and improving drainage systems to manage the city's unique geology. Educating residents about their city's geological heritage can foster a culture of preparedness. Public campaigns, museum exhibits, and school programs can highlight the volcanic history of cities like Honolulu or Lisbon, encouraging residents to understand and respect the land they live on. Cities built on extinct volcanoes are a testament to humanity's ability to thrive in diverse and challenging environments. Yet, these urban centers also remind us of the Earth's dynamic nature, where even extinct features can pose risks. By understanding the geological foundations of these cities, acknowledging their potential hazards, and taking proactive measures, we can ensure that these urban giants continue to thrive atop their sleeping counterparts. The unseen threat beneath our feet may be rare, but it is a powerful reminder that the Earth's past is never truly silent.